All right, shall we get started then?
Yeah.
All right. Welcome to the last day of Code Astro. Thanks for everyone for coming on Saturday. Yeah, we had some scheduling conflicts, so we had to kind of put it on this week, so it's kind of squeezed it in on Saturday. But thanks for everyone for coming. Yeah, so this morning we're going to start off with a career panel, just with people who previously been in astronomy, who or now have or are currently worked in industry, and talk about some differences and similarities between the two. So maybe the first thing we can do to start off with is just we can introduce ourselves and talk about our backgrounds in the industry, and then we can go and answer questions. This should be pretty free form. Yeah, so hi, you've seen me. I'm Jason. I've been in academia for a long time, and over 10 years now, but 10 years ago I did a software internship at Microsoft. That was before I even went to graduate school, but so I have some vague memories of how everything works and developed some strong opinions since then. But here, probably the people here on the panel have a bit more recent experiences and probably can tell you a bit more. Simon, you want to go next?
Yeah. Hi, everyone. Been in the industry ever since undergrad, so been in the industry for about 6 years. Senior site reliability engineer at Roblox. I work on our hybrid cloud deployments across our global infrastructure.
I'm Sarah. You've also seen me a lot over the week. But I'm on this panel today because I'm doing an internship this summer at Google on the image search ranking team. I'm also a rising fourth-year astronomy PhD student. So after I finish the internship in August, I'm going to enter back into my PhD program and hopefully finish at some point.
Hi, I'm Denise. I got my PhD here at Caltech in 2019, and since then I've been working at a data science startup, or at a startup as a data scientist.
And the place is called?
So the company I work at is called Prescriptive Health. We do healthcare related software related to optimizing prescription drug pricing.
Cool. Yeah, so this is gonna be a pretty like informal quick Q&A generally. So for people in the room, feel free to raise your hand. We'll call you. You can ask questions. For people in on Zoom, you can either raise your hand on Zoom and then we can call you. You can unmute and ask a question, or you can put a question in the chat and I'll read it out to our panel and we can discuss the question there. So maybe while people are still thinking of questions, I can start off with the first question. Maybe you can, I'll talk about like your career trajectory, like what is your experience switching between academia industry, and how did that work for you?
Sorry.
You can go.
Okay. Let's see. So for my first step was my first introduction into coding was with a actually student taught course, kind of like this, at Berkeley. We call them decals, where students can kind of host any kind of course they want to do as long as they prepare themselves. So it was entirely organized by the student body themselves, and some upperclassmen decided to teach the underclassmen that, hey, in astronomy, we kind of need to know how to code. And that was actually my first time touching any kind of code, and I kind of got a little bit of an interest in it. And from there, I thought I should have some formal training in it. So I took a couple of courses, ended up minoring in CS as well. Did a lab kind of internship thing with Jason here at the PyClip, and then got my first job out of college at a fintech company out in the East Bay. So that was kind of the career progression there. And then once you kind of get your foot in the door and you have your first job, it gets a lot easier to get other jobs from there. And then after that, a recruiter reached out to me for Roblox, and then I've been there ever since.
Cool.
So I started my PhD at Caltech in astronomy in 2019, and I think during my second year-ish, I think feeling a little nervous and also a little like disenchanted with like academia, and I was sort of worried that I wouldn't be able to get a professor position. And at that time I was like, oh, I don't know if I can stay in academia if I don't want to be a professor. And I talked to Jason about it, and Jason said, well, when I was in grad school, I always felt like, if it didn't work out, if I didn't end up wanting to become a professor, I could always go into tech. And I felt like at the time I was interested in tech, but I didn't really know what it would look like to actually get a job in tech. And so I decided to try and apply for tech internships because I thought that would be a nice way to sort of try out being in a tech environment and seeing what I could do there. And so I applied for, I think I probably applied for like 50 internships and got one, but that's all you need. And yeah, so the experience of applying was mostly like, I ended up doing a bunch of technical interviews in coding. And so I spent a bunch of time before that, like reading the book, Cracking the Coding Interview, which is like the book that everyone suggests when you're preparing for coding interviews. And just sort of doing a bunch of practice interviews. And yeah, so I did those interviews and I got this internship. And yeah, that's my plan. So I don't know what I'm going to do after I graduate, but that's part of what I'm, why I'm doing this summer is trying to figure it out.
The Bible.
The Bible, yes.
So I had very little formal training in programming. I had like a couple of programming classes in undergrad, and that was it. Other than that, I just, I did plenty of coding in grad school in astronomy, but it wasn't very, not up to tech industry standards. So I've learned most of what I know now on the job, but it's been good. My career path was sort of interesting. I didn't really decide that I wanted to go into industry until I had applied for a few postdocs and realized that I wasn't really, keen on that path anymore. And so that was when, people always ask me like, oh, how do you go into data science after a PhD? And I'm like, well, I don't necessarily recommend doing it the way I did, but it worked out for me. So, but yeah, anyway, I started applying for postdocs, realized I wanted to go into industry. And so I went into industry as a data scientist right after my PhD. And yeah, I've been learning pretty much everything on the job. But I think over the last 3 years, I've learned a lot, and I think I've looking back, I think I've come a long way. So I guess the moral of the story is, if you feel unprepared, don't despair, because there's always time to learn.
Cool. It looks like we have some questions on Zoom land, so I'll go ahead and read some of these. So the first one was to Sarah. Could you share your experiences regarding getting the internship at Google? How hard was it? How much Python was? How much of it is Python related, or depends on your coding skills?
Yeah. So the internship that I applied for is specifically our research internship. And it's aimed at PhD students, which was really nice. And I think that was part of the reason why I got this position, rather than like the other positions that I applied for that were specifically like software engineering internships aimed at primarily undergrads, I think. So I actually found out later that other research interns applying for the same role that were in like computer science or applied math PhDs didn't have to do coding interviews, that they only gave me coding interviews. So I think it's sort of like Google sort of trying to figure out like what this program actually looks like. I think it's sort of new, and they're deciding what the requirements are in a sort of ad hoc way. Yeah. But in retrospect, I'm glad that I had to do these interviews, because I think it was a lot less scary than I was expecting it to be, and I thought it was really good practice for me. If I do want to get a software engineering job after I graduate, I will probably have to do more of these interviews. And I think it was good to do these for the first time in a sort of low stress way. Like I was sort of thinking at the time, like if I don't get an internship, it's fine. Like I'll just keep doing my PhD. So the question was like, how much Python did you have to know? How much did it depend on your coding skills? So you can do the interviews in any language you want. It doesn't necessarily have to be Python. I think Python is definitely one of the most commonly chosen ones. And I chose to do it in Python because that's the language that I'm most familiar with. I don't think there was not, the interviews are not so much about your knowledge of Python as your knowledge of like sort of fundamental data structures and algorithms. So it wasn't like, you know, I don't think they cared about like if I forgot the syntax for something, or if I like, you know, couldn't write code that, you know, would run through on the first time. They were more interested in my like thought process and trying to figure out how to solve particular problems. If you're interested in doing these types of interviews, every person will give you the same advice. It's just like read Cracking the Coding Interview. It's an excellent book and it has lots and lots of practice questions. The other thing I'll say is that my partner actually applied for jobs in industry at the same time as me, which was really great because we were studying the book together and we did practice interviews for one another. And he said something that I remember that after he did this whole experience, he was like, you know, coding is one thing and talking is another thing, but coding and talking is a third thing. And that's the most important thing to practice. Is not like, he was like, I'm so glad that we practice like coding and talking together, like, and not just studying all of the algorithms to death and not just like talking about it, but actually doing those two things at the same time. I think that was the most helpful thing to prepare for these interviews for both of us.
Cool. So I think you also partially answered the next question, was how do you prepare interviews for industry jobs, but also follow up, are the skills you learn from Astro transferable anyway?
Oh boy. There's lots of different things that people do to prepare. I personally, and I do recommend this, it might sound a little bit, but I prepare a few burner interviews where like, it's kind of like going on like a roller coaster. It's like the first roller coaster is always the most nervous one. And after that, it's like, oh yeah, roller coasters are fun, I forgot. So I'll like line up a couple of companies where I don't necessarily care about getting in or not as burner interviews to kind of get the nerves out and get my like warmed up again. And then I'll line up the more important ones. You can also like practice interviewing with friends. If you have people that are experienced with interviewing and know how to conduct a software interview, you can practice with them as well. That's also helpful, but it's nothing really beats like the real thing. It's like being on site and grilled for like however many hours with however many engineers you're not familiar with. It's different. And also to your point, coding and talking, way different from doing the two very separately. You're sitting there like, I know this algorithm, but then like doing it on like a whiteboard or like in front of someone, it's completely different. I'm sure some of you experienced it while doing like the coding pairs where you're like coding in front of someone, someone's watching you code while you like Zoom share or something. Is very different. But my typical routine is I'll go on leetcode.com and do a bunch of problems there for like a month, and then practice interviews.
Yeah, I can speak to the experience of doing data science interviews because I think it's a little bit different than how it typically works for software engineering positions. So for most of the data science interviews that I've done, it hasn't been so much like cracking the coding interview style of problems. I have had a lot of coding interviews. They've been focused less on knowledge of algorithms and data structures and so on, and more about being comfortable with manipulating data. So most of my interviews have been specifically in Python. Some places have expected me to have familiarity with pandas. I think I had one or two interviews in SQL, which I did not do well in because I did not prepare enough in SQL. Yeah, I think, well, my experience with interviewing has largely been trying to find the company that's looking for someone who wants to learn on the job, which is a fine strategy. It's been my strategy. If your strategy is to be more prepared for a wider variety of things, then if you're looking at data science, I recommend being comfortable in pandas and not necessarily it doesn't necessarily tend to focus so much on the traditional coding type problems, but more on, you'll be given a data set and, figure out some things about it.
Yeah, to your point, it also is very important to understand what you're applying for. So very often, like, well, they have to, but they'll post a job description. And in the job description, if it says like, this is software engineering versus data science versus systems engineer, you'll have very different interviews.
Cool. Let's continue on. And in-person people, feel free to raise your hand or something like that, or just like some way. Oh, you want to go first?
Yeah, sure. So my question is, I guess I'm planning on graduating next year, so next summer, and I would like to not be unemployed after I graduate. So I think this is the year I need to start looking, because I would want a job in industry, probably data science actually. So I want to know what are, in your guys' opinion, are some of the things that I can do right now that will, prepare me to be more attractive. Because I feel like, a lot of my mentors and advisors are not in industries, they're very concerned with publishing papers and things like that, but that's not necessarily something I should care about so much.
Just to repeat the question to Zoom land, the question was, if I'm looking into going to like a career in data science about a year from now, what are the things I can do in kind of a year time scale to best prepare myself for data science or industry position?
I think
Yeah,
you should probably go first.
Yeah, I can speak to that. Yeah, so I mean, it depends a little bit on your background, whether you're coming out of school with a degree in data science or something in more pure science. I don't know what your background is, but anyway, astronomy. Okay. Yeah. So I think you're already, based on your resume, you're already going to be an attractive candidate. And so I think, in order to prepare for interviews, I would recommend brushing up on statistics, because that's, they'll always, grill you on your knowledge of statistics. Being comfortable with working with data sets. So I would recommend probably going on, I think Kaggle has practice problems that you can do. And so that's the sort of practice that I would recommend doing for data science specifically, is doing data science problems, not necessarily just pure coding problems. And just practice being comfortable talking about the experience that you have and how it translates to data science. So being comfortable talking about how you've worked with data and what kind of analyses you've done on your data, what kind of statistical problems you've encountered, what kind of errors you've encountered, and how you've dealt with them. Because they're they want to see people that are hiring for a data science position for somebody right out of academia. They're not necessarily looking for you to be an expert in everything. They just want to know that you understand how your skills can transfer.
Yeah, I'd also add that I think getting interviews when you're applying for software engineering or data science is not the issue. If you make a LinkedIn and you list yourself as being comfortable in Python and statistics and a couple other things, you'll probably have recruiters reach out to you. It's more about preparing to answer those types of questions, doing practice problems. And I also mentioned that I found doing practice, at least for software engineering, doing practice problems and finding practice problems was so much easier than finding practice problems for my qual for astronomy. It's the requirements are so much more apparent when you're applying for software engineering positions, and there's so many resources out there. If you just Google I want to do software engineering practice problems, or I want to do data science practice problems, there are tons of problems out there and tons of resources. So yeah, and like Denise was saying, reframing your experience in terms of things that they understand this is something that I also had to learn a lot. Like I had a lot of recruiters. I had like 5 interviews that started with like, so how long have you been working at Orbitize? I'm like, it's not a company, it's a project. And they're like, but what? They didn't understand. So
To be fair, it could be a good startup.
so yeah, just sort of emphasizing the aspects of my experience that were like, contributing to a large Python package and dealing with data and all that type of stuff, like putting it in sort of terms that they're familiar with and they understand. It's a big part of that.
I think if you're a year out, definitely what you can do is work on your resume, because that's what you're going to be presenting to them. Also, if you are a year out, everything on your resume is fair game to ask. So make sure you brush up on everything that you put on your resume and you're able to explain clearly everything you've done. If I have a candidate that's in front of me and is fumbling to talk about what they've worked on, it's not a very good sign, right? So you want to be able to clearly talk about everything that you put on your resume and be able to like actually elaborate on everything you put on there. To that point, building your resume out is an opportunity you have now, right? You're a year out, so you have an opportunity to actually, there's a year you need to fill in, right? So you can work on personal projects or things like that. I would recommend you actually, if you have an idea of what kind of companies you want to work for, to check out like generally across several different companies that you pick their job listings and their skill requirements, because like Denise said, you don't need to know everything. You just need to match their skill points, right? So look at the job description listings and look at the points that they're looking for, and then try to like see if you can work on a project that kind of matches those things, and you can tailor your resume to those career paths, right? Like if you're a data scientist, they're not going to really care too much about like, oh, how much infrastructure coding can you do? It's not going to be a thing you need to know, right? So you can like kind of tailor your resume now that you're a year out.
Can I follow up on that? So what's so a resume for industry is a lot different than a CV for school, right? Because CVs are like several pages and a resume is just supposed to be one. So you shouldn't include things like publications, for example, on like a resume. But how do you include things like Code Astro, for example, because that doesn't necessarily fit into experience, but I feel like things like that are something that would be like attractive. Yeah.
I feel like resume.
So hold on a sec. So the follow-up was, how do I convert a CV to a resume? And like, for example, how do I include things like Code Astro in something like a resume?
Yeah, I feel like we can have our own little workshop on like resume building. There's so many things you can do for your extra resume. But the way I see it in the industry, at least, is you would list separately like you have different headers for it. So generally we want to see like 1 page. 2 pages is fine and stuff, but then I have to read 2 pages and it's like so I would like split up your actual resume from like basic information about yourself at the top and stuff, and then you can split up like experiences where like you would have like internships, previous jobs and things like that. Then you would have things like skill set or personal projects, like have that in a separate portion, that way they don't confuse like Orbitize, right? Is that a startup? What is that? Relevant course material or something. So you can have like separate like headers and say like, I've done this. And this is another thing, right? You tailor your resume to the application. So it feels useful to put Code Astro on there and say, hey, I published a Python package out there, right? And someone's like, hey, we work in Python. Oh, look at this, a workshop for Python. You would put that on the resume with the specific heading that you're looking for.
Cool. Shall we continue? We can go to Zoom for next one. So to the panel, how did you find the transition to industry? How was the culture, in particular, how was the cultural difference between academia and industry to manage?
I almost went directly from
School
to industry, so I don't have too much experience in this. Does someone else want to?
Yeah, sure. I had kind of an interesting transitional experience because I finished my PhD, then got hired, started my industry job, and then 6 months later, the pandemic hit. So I had like 6 months of working in person at a company and then started working remotely. But yeah, I think it was a little bit of a learning curve in terms of, you know, just like generally the way things worked and the different sort of expectations. And you know, for me personally, like I'm not a morning person, so you know, having to like wake up in the morning and get there at a certain time, you know, it was a little bit of a learning curve. But I think if you find the right position, then I think you know, if you're in a position with a good manager and a good team, they'll help you get acclimated to the cultural shift. I think I found you know, I had a really good mentor in my first boss in industry who really kind of showed me the ropes. So it's definitely, it's challenging, but it doesn't have to be daunting. I would say cultural fit is an important thing to look for when you're doing your interviews. I think, you know, don't be afraid to trust your gut. If you interview someplace and you think, oh, you know, I don't think this is a place that I would really like working, then don't work there, because it's important to get that right fit. And I think finding the right fit goes a long way to helping making the transition more manageable.
Yeah, so I've been at my internship for 3 weeks now, so take what I'm saying with a grain of salt because I don't really know too much yet. But I think Google is obviously a huge company, and it's been kind of fun and interesting to get to know like the different like little subcultures within it. Seems like Google search is sort of like the nerds. A lot of people that I work with on that team like also have PhDs and like they're all really interested in like algorithms and stuff. And then like YouTube is like the jocks. So yeah, there's all different. Yeah. Yeah, they're like, yeah. So it's there's definitely subcultures within the individual companies, the individual teams. Something that I've been really like impressed with in my first 3 weeks is the emphasis on pedagogy, like the amount of time that people at Google have put into like making tutorials and trainings and stuff like really accessible and really interesting. And I think it's really impressive. And coming from academia, where like if you tell someone you want to learn something, they just like, you know, point you to 3 really dense papers. Like it's very different for like than to like, you know, have tailored, you know, curricula. And it's very clear that they work with actual educators to prepare these trainings and stuff. Yeah, I think similar, just since the culture like varies from team to team, at least from what I've seen, it seems like also the sort of emphasis on inclusivity, I think, varies from team to team. Like I think Google as a company emphasizes it more than like Caltech as a company. But yeah, it definitely still varies. And like you know, one of the first things I did when I got there was like look around and just see how many other women I saw. And it's, you know, it seemed like it was better than what I have experienced in academia so far, but still not like what I would want it to be. And, you know, obviously this is just me like looking and, you know, identifying people's gender by looking at them. So it was not good, but it was just, you know, sort of feelings about like, you know, how much you, yeah, like what types of people you see in the room. So
I'll just add that I think in industry, just like in academia, a lot of the kind of culture is also dictated by your team that you work on. And just like how in academia, a lot of that, your day-to-day experience is dictated by your research group that you work in. But the one nice thing about industry is generally it's a lot easier to switch inside of a company to a different part of the company, to a different team. That happens all the time. That's not something that's looked down upon or anything like that. That's usually common and expected, that you work on something for a bit and you want to switch to something else. So that's all. That's one way you can like move around. You find out this, I think this is actually more interesting to me. I can move there. Whereas in academia, you kind of like have a research focus and it gets narrower and narrower over time kind of thing.
Yeah, I think actually every person that I've talked to at Google so far that has been there for more than a year has worked on more than one team. Like it seems very, very easy and possible to transfer to even a completely different team. People also, Google has something called the 20% program, which is where you are, you can sign up to spend 20% of your time working on like any other project within Google. So you can just reach out to a team and say, hey, I want to sign up for this program and I'm interested in doing like this. It's like a side project type thing in academia. You can start a side project with them, and if you like them, you can transfer to that team. So I think a lot of people find it very easy to move around internally through this program at Google specifically.
Yeah, your experience is gonna vary wildly. Google is like a gigantic tech company, so they're gonna have a lot of people working on documentation, training, and stuff like that. If you go to like a small, like 5-person startup, it's gonna be very similar to your research team, I would say. So it's gonna vary wildly between like the size of the company you're going with, and then even within the company, the team you go with, it's their own little microcultures. I will say though, there are a lot more, like a lot of like academia to industry transitions. Like I see it all the time. So it's not going to be like you're some weird specimen coming like, oh, what is this academia person doing here? Like, no, it happens all the time.
That's a good point.
That's especially true in data science, I think.
Yeah.
My team right now is 5 people and we all have PhDs. So data science is full of people like us.
Cool. Chrissy, do you have a question?
How does the work industry and academia, especially with respect to things like work-life balance, performance pressure, and just enjoying your day-to-day life?
So the question was, how does work-life balance compare between industry and academia? Things like work-life balance, performance pressure, and enjoying your day-to-day work.
I can kind of just talk about my day, I guess. I'm not.
Yeah, go ahead.
Let's see. Depending on the day, if it's like a busy day or not, I might start to leave home around 9:30, get there around 10:30. Then we have a meeting at like 11:30 for stand-up, where we talk about what we did for the day. Then we have lunch at 12. 12 to 1. Then we work till 5. And everyone goes home and I'm alone because I don't want to hit rush hour traffic. So I'll leave around 6:30 or 7. If it's a busy day, but that's like on an easy day. On a busy day, I'll go in. Sometimes I won't go into the office and I'll just be working from like, the hours will vary depending on what happens. If something goes wrong, we've had one case where we had engineers stay up 72 hours or so for like a major outage. And that was, it has its ups and downs, but generally it's around the average between the two, I would say.
But that's also related to the job that you're in. It's like an online service.
Yeah, I'm a site reliability. The site goes down, I'm on the site. So it does depend on what you're working on. That'll like, if you have a project in production and that project goes down, you're going to be working on the project.
I think search is so I said that search is the nerds, and it seems like the culture on search is very similar to the culture in academia, where like a lot of like Google search works. It's not really it doesn't seem like it's a life or death situation most of the time, at least. So a lot of the projects that people are working on are pretty like open-ended, like researchy type projects. And so for that reason, it seems like the work-life balance on that team in particular is really good. All of my managers don't that I've seen like don't work more than 8 hours a day. This week I told my manager I'm coming here to do this, and he's like, "Cool, I'm gonna go camping for 5 days." Like, you know, it's something that like, at least the, you know, comparing the professors that I've interacted with the most here at Caltech with that, like, I think it would be a lot harder for them to do something like that. So it does seem like, at least from my experience, that there's more flexibility and free time, better work-life balance. But yeah, in my limited experience.
Yeah, working at a startup is a little different from working at a big company in a variety of ways. And one of those ways is there can be a little bit more variability in how busy you are from day to day or from week to week, depending on how many deadlines there are. That said, even though sometimes you can be busy, there's definitely the expectations are a lot more straightforward, I would say, than they are in academia. And so I think the work-life balance situation is a lot better. So even when I'm busy, you know, I'm not feeling overwhelmed with work, because I think the expectation is that I'll work a reasonable amount and then stop and then come back to it the next day. Yeah, so my typical day, my team has our daily morning meeting at 9:30, and then and I work from home. So I wake up, get ready, you know, log in, have this virtual meeting at 9:30, and then I'll work, and then we have another team meeting at 4 o'clock. And sometime, and then after that meeting is over, sometimes I'm done for the day, sometimes I'll work a little more. But yeah, I'm never working into the evenings or anything. So I would say, yeah, the work-life balance is much better than it was in academia. And I think also, you know, my team and my manager are really understanding if, you know, you need to, you know, if you need a little flexibility in your schedule, you know, to take your car to the shop or whatever, you know, like whatever it is, it's yeah, there's definitely flexibility. So, you know, you work hard, but it's definitely very reasonable.
I will say it's also really dependent on what you're looking for. There are a lot of different factors that go into it, like when you're going through the interview process, you're also interviewing the company on what their work-life balance is. You can totally go to a company that's really fast-paced and working all the time if you want to, if that's what you like, right? That's what the whole interview process is about, is finding a good fit for yourself as well as with the company. So if you want a chiller lifestyle, you can interview a company that specifically promote that, versus a company that's really fast-paced and wants to do more. That's up to you. It's also within your career level, you can also choose how hard you want to work in a way where you can just meet the bar, or you can constantly exceed the bar and progress your career. That's also something you can also choose to do. You can just chill where you're at if you're happy with where you are. And if you decide it's time for promotion, you wrap it up.
Yeah, I'll note one difference is that in academia, we have all these temporary positions until you get to these full-time, research scientists or faculty positions, which are, often difficult to get. Whereas in industry, your entry-level positions are permanent positions. You can stay there. You don't have to climb the full career ladder to manager or vice president of something kind of thing. So you don't have to climb that ladder. You can start at entry level, but that's still a permanent position for people. So I think the work-life balance also is affected because of that.
Yeah. Also, you'll see if you do some research on salaries for engineers, you'll see the senior engineer band is anywhere between this low end to this ridiculous high end. The reason for that is people just choose to stay in that position for the rest of their lives. So the salary band for that is completely out of whack.
Yeah.
I'm not quite sure how to phrase this, but I want to ask about how easy it is, or how you go about finding meaningful work when you're working in data science industry. Because I remember I applied for some jobs after undergrad, and one of the positions I got, I would have been building software for McDonald's, and I looked at it and said, I can't do this.
how easy is it to find a job that is fulfilling you in the same way that like I think a lot of us came to grad school to look for, scientific work that we found meaningful.
Yeah, so to repeat the Zoom, how do we find a job? How do you find meaning in your job and industry? Like a lot of us, in academia are working in science, we find that really meaningful, but maybe won't worried about not finding some other things in industry. And how do you approach that?
Or is it even important that you're working people, or you just
Yeah.
like
Or
you
yeah.
to just go in, do your 9 to 5, go home, and then do the stuff you care about? Like, what's that like?
Yeah, or whether it's even important or not to find meaning.
Interesting question. That's like, but yeah, that's very difficult question to answer. I would say, basically asking me, where do I find meaning in my life? I will say, like the first time I got my job, I was like, am I really gonna work at a fintech company? And
You
I
guys
wasn't.
explain what fintech is.
Oh, fintech. Sorry. I hate acronyms, yet I still use them, so I'm part of the problem. That's another problem in the industry where it's like everyone's sprouting. I hate it. Sorry. Let's see. So yeah,
So
I was working at fintech is financial tech. It's a company that deals in like finance, and then like it's the tech portion of it, like Chase and stuff, like the back end. So I was looking at the company at face value, and I was like, I don't know if I want to work on this. I don't know how interested I am in the mortgage industry right now as like a 22, 24-year-old. Not gonna get a house this time, right? But what actually ended up I ended up liking was there was this crazy at the time principal engineer. So this is where I've talked about it. The interview experience is actually a really important part of it. The recruiter for it was this really crazy principal engineer that was like, I want to gather a team of like random scientists and make this like experimental, fast-paced cloud team that just like responds to like requests for the company really quickly, build something up in the ephemeral. That's ephemeral. It's supposed to live in the cloud just to serve this one purpose. Come down and then like do whatever we need to do really quickly, kind of like a strike force in the software world. And I found it to be really interesting. I like working with code and making systems run. And this was a great opportunity to just kind of learn that under this crazy principal engineer. And the actual team I was working with, it felt really good working on this project that wasn't necessarily like, I didn't touch any of the fintech stuff, right? It was working on cloud resources and making scalable systems and helping other engineers with their careers and their jobs and making their processes go. And then at the end of the quarter, it's like, oh yeah, you helped us save this much money. I was like, wow, I'm worth this much. So I found that really fun and personally fulfilling for me, where it's like, I'm building out these cool systems and it's helping, I guess, the mortgage dream of America. But it was more like the whole interview process and figuring out things that I like to do. And that's basically what I do now. Like whenever I interview at a company, it's like, this sounds like a cool project. I want to take this on. And yeah, working on my personal skill sets for me.
yeah, I'll add that like the quest for meaning has been, something that I've thought about a lot, and it's sort of something that drove me to apply for an internship in the first place, was me sort of questioning whether the astronomy work that I was doing was, meaningful or interesting or whatever, however I was defining those words in that moment. And yeah, I have a lot of thoughts about it. I don't know if I can put them all into words, but I think I'm trying to figure out if I can find a meaningful job to do in this sort of new context. And I've been talking to a lot of people, and it seems like there are places in my mind at least to find meaning and impactful work. So one example is that I had coffee the other day with Casey Stark, who was actually on this panel last year. Yeah, and he works at Google Search as well. And so we just by coincidence, we're like one building away from each other. And so his work is really cool. He works on like trying to use machine learning to identify like harmful web pages, like web pages that are like, you know, promoting false information or like, you know, trying to like, you know, induct people into like white supremacist cults and all sorts of stuff like that. And I was asking him like, you know, is that I can imagine that that's really like intense and really like sort of weighs on you and whatever. And he's like, yeah, like some people like really hate it and like really burn out really quickly because you're seeing all sorts of like crazy stuff on the internet. And he's like, but I love it. Like he was like, it's cool to like see your algorithms like, you know, downweighting that stuff on in a way that's going to affect billions of people like in real time. And that was really like kind of a game-changing moment for me because I didn't really think about like I was thinking about I'm just rambling at this point, but I was thinking about yesterday too, like when Jason was talking about the discrimination software, like several of the examples that he gave were image search, and that's literally the team that I'm working on at Google. And like I can definitely see how like if you're sort of hyper focused on improving one part of the algorithm, you can end up causing a lot of harm because you're not considering like the broader ramifications of the changes that you're making. And so that's scary to me. Like on the one hand, like I don't want to be responsible for that, and I don't want my biases to affect billions of people. But on the other hand, it's, you know, if I think about it, and if I you know, talk to lots of people about it, maybe it's a real opportunity. And so, short answer, I don't know. I'm still trying to figure out how to find meaning, but I think there are. I think the takeaway that I would say is that there are opportunities to find meaning and impactful work no matter what you do. And the value of doing something that is interesting and exciting to you and lets you have a life that you're happy with is definitely like undersold. I think that's really important. The world needs more happy people, more content people, more people that have time to do things that they like outside of work. I think that's my philosophical.
Yeah, this is a super interesting question. And obviously the answer is going to look different for everyone. But I can talk about my personal answer because I think that this is something that I've thought about a lot since I've been in the industry. And I think I've kind of, you know, found my personal answer to this question, at least for now. So the first thing that I would say is with the kind of background that you all have, you can afford to be choosy in the types of jobs that you're seeking out and interviewing for. So when I've gone through my interview processes, I've definitely had a list of things I will and won't do. Like there are certain industries that I don't want to work in and certain types of data science jobs that I don't want to do. And that's not to say that you know, all of those industries and jobs are wrong or bad or that other people shouldn't do them. It's just, you know, things that aren't fulfilling for me. So just as an example, I know that I personally am not interested in working in like business analytics type of data science. I'm more interested in the type of data science where the data science model is the product. So you know, so I prioritized that when I was looking for jobs to apply to, and so you know, and it's kind of hard to get over the imposter syndrome there, like, oh, I have to just apply for everything because I don't know where I'm going to get a job, but that's false. You really can't afford to be choosy, and so it's worth being choosy because then that makes the decisions easier down the line. The second thing I would say is to echo what other people have said, in that when you're interviewing, you are interviewing the company as much as they're interviewing you. And so you can really get a sense of like whether the people that you're going to be working with there are feeling fulfilled in their jobs and what the day-to-day looks like, whether it's something that's going to be fulfilling for you. You know, I think it's also important, whatever job you end up in, to be able to reflect on your own, you know, ethical principles and be able to bring that to whatever job you're doing. You know, like kind of, you know, this goes along with what Sarah was saying. understanding, how your own biases might be reflected in your work, or how unforeseen consequences can crop up with unsupervised software, and how to be mindful of that and correct for it. So I think, there are a lot of opportunities in industry to find work that is not going to be personally meaningful to you, and also a lot of opportunities to find work that is personally meaningful to you. I think the main thing that I would say about industry is there are so many different things out there that half the task is just narrowing down all of those opportunities to find what you specifically are interested in. And if you're able to do that, I think it's very, very possible to find something that's fulfilling for you, and something that makes you, feel good about the work that you're doing.
Cool. So we have 5 minutes left. So if anyone has any remaining questions that I forgot to answer on the that we forgot to repeat on the Zoom, because I tried my best, but I might have missed a couple. Or if anyone has questions in person, yeah, let us know. I just want to add, since just in my context, that I did an internship at Microsoft like 10 years ago before I even applied to grad school. And then I decided they actually gave me a return offer. So like you can have a full-time job straight out of college, or you can apply to grad school. And I picked applying to grad school, which a lot of people question, but I personally found, so that's why I'm still in academia. I found that the technical challenges, like the technical things I worked on day to day, were interesting, but in the big picture, I just felt like I was just like a small cog in this giant machine that is Microsoft, and produces like a few big software. And you're like, if you go to this drop down menu and go here and here and here and here and here, and then click on this checkbox, and you can find the thing that I also contribute a little bit to, kind of thing. And that I felt like that's like, it was comfortable, but I felt like I wanted to do something like a little bit more interesting than that, basically. So that's why I've stayed in academia. But I also found that like switching, I know, like now I know what the other side is like, and I know like what is my tolerance for work-life balance in academia versus what the things I think are doing are quote unquote interesting. And that if basically the amount of the work-life balance, or like my personal like enjoyment of like outside of work is like being deteriorated too much by academia, I always know that there is this alternative I can go back to. I know what it's like. I know that I may not enjoy exactly the fulfilling like big picture thing, but like the technical work is still interesting, the pay is good, the benefits are good, and things like that. So kind of have to kind of, like Sarah said, weigh kind of these two and think about for yourself like what it's like.
Yeah, something also nobody asked, but I have to add this. Like, you think you understand how good the perks are at a place like Google, but you don't. Like, it's crazy. Like, that like 3 free meals a day, like 3 massages. Like, it's crazy. Like, there's gyms in every building. Like,
Advertising.
I just on the first day walked in, and it's like, this is a whole different world. Like, it's unbelievable. Like, yeah, I don't know.
It's like living on a college campus, but everything is free.
Yeah.
Your experience will vary depending.
Yes.
You
Right.
do pay a price for it.
Any last questions for anyone? Make sure I don't miss anything.
I will say, I feel like a lot of the uncertainty that I get from industry or from academia to industry is whether or not you'll be a good fit, or whether you're ready for this or that, or like you'll find this or that. You have to understand that it's so varied. There's so many things out there. It's highly unlikely you won't find something that fits for you. The bigger problem is your threshold for applying and looking for what you actually want. That is the bigger issue, because a lot of people will just kind of jump at the first offer they get, and then you have to understand that this will completely determine your experience, right? Where you go and what team you have, who you work with, is going to determine everything. So being more selective about that is one thing I would definitely encourage. Be selective about the process. Like the companies are going to be selective about the candidates that they take on. Be selective about who you take on as well. It will determine everything.
And if you make a choice and it turns out to be not everything that you were hoping for, you can quit.
Yeah, just walk out. Literally leave.
There are lots of other jobs out there. Find another one. Yeah.
Cool. There's one final question, I guess, in the last minute we have. Could you give some final thoughts on how to manage uncertainty in the process of changing paths, finding a job?
Oh, yeah, I had a big problem with that the first time because I was sitting there like, I graduated, my lease is about to end, I have no idea what I'm gonna be doing. But that fear kind of went away after I realized there, again, are so many positions and companies and stuff out there that now if I were to be, like, if I were to quit now, and like, I know that if I took a month to prepare, I could find a job because it's out there for me, because I know I have the skill sets and stuff, but that kind of comes with being in the industry, right? And knowing that like, I find myself to be a valuable candidate. I do add to the companies that I go to. So the security in that is that I know that I can find a job if something were to go wrong, right? Which is why I'm emphasizing that you should be more selective about where you go, because there are so many companies out there that, and so many startups out there that it will be something that really matters, I think.
Anyone else with closing thoughts?
I guess, I don't know that I have thoughts, but I guess it's hard because, like, you know, especially at this point where all of you are in right now, or a lot of you are in grad school or postdocs and thinking about switching, like, you might not be able to afford to like take a month and, you know, apply for new jobs. And I don't know that I have like good advice for that, but the, like, you know, part of the reason why I wanted to do an internship in grad school is because the stakes were pretty low at this point. Like I could always just keep doing grad school. I didn't have to do an internship, but it felt like it was a way for me to like sort of take a step without putting my foot all the way down, you know? So yeah, the process of applying for an internship in grad school was a lot easier than I thought it would be. Like I thought there would be a lot more institutional barriers, but it was pretty straightforward. So I think that's one way that you can, if you have time, like I think it's definitely worth doing. And like financially, I think it was a really good decision for me because I didn't have to take time off to apply or anything. And also, you know, I'm making money in the internship, which is really nice too. So yeah.
Yeah, I would say, yeah, I mean, if I'm being honest, the uncertainty for me was very stressful when I was applying for my first industry job because I was kind of flying, I wasn't very prepared. I was kind of flying by the seat of my pants. But I would echo the sentiment that the stress level goes way down once you gain, you know, once you have more experience with the process and once you gain some confidence. So if anything, I would say just start thinking about it early and, you know, start early and start slow with, you know, looking at jobs and applying for jobs and maybe even taking interviews because the more experience you gain in a relatively low stress setting, the more confident you'll feel when, you know, when the clock really is ticking, I guess.
I would half agree and half disagree. I would say start early, yes, I agree with that. But the start slow part, I would say just shotgun, literally catch a nut as far as you can go, apply to like hundreds of jobs or whatever. Most of it is, it's the first time is going to be stressful mainly because of all the rejections you get, but it really means nothing. Most of it's going to be like, oh, we actually don't have budget for this, and then like they'll like trash or something. Like it really doesn't speak to you as a candidate. A lot of times it's more of a logistical thing on their end. And it can be the smallest thing that changes. So it really does not reflect upon you as a candidate. There are a lot of times where I was like, I'm interviewing candidate, I'm like, why did we not get this candidate? and then HR randomly just decides, nah, we're not gonna do this, and it's the most frustrating thing. But like, just really casting it as far as wide as you can, and work with the companies that you like. It does get discouraging the first few times you do it, but then after the first few times, it's like, okay, that one's off the list, that one's off the list. Like, I'll get rejected at so many different companies. It really is just a numbers game.
Yeah, I think people also don't, like, when I say I put in 50 applications for internships, like, I think people in academia sort of like shudder to think about writing 50 applications, but like, to apply for some of these internships, you just submit a resume. Like, I would just spend a day like clicking around LinkedIn and just submitting resume after resume, and that counts as applying for a job. So it's a lot easier to just cast a very wide net and apply for a ton of jobs than it is. And like, it's very different from writing a postdoc application.
That I would agree with, actually. You can definitely do a large volume of like the low effort stuff, like just clicking apply. I guess I should clarify when I said start slow, I mean, don't overwhelm yourself with like taking too many interviews or like trying to read too many books or do too many practice problems. But yeah, but you can click apply on a whole bunch of jobs. Because you will get rejected from most of them. It's just a numbers game. But yeah, the low effort stuff, feel free to just
Go ahead.
go ham. Exactly.
200 applications, 3 respond. Yes.
All right, so I think we should wrap it up here. Let's give our panelists a round of applause. All right, we're going to start back up in 3 seconds. Okay, so we're going to do the next half an hour. We're going to do like show and tell for with the entire workshop. So basically just share your screens and unmute yourselves, and basically for the people in person, you also need to log on to Zoom and share your screens, but don't unmute yourself. We'll use the microphone here. I think we already have our first group that wants to go. So you guys want to come up to the podium? Share your screens and then take it away.
Okay. I don't think I have to turn on my sound because I think you can hear me off of Jason's computer. Okay, great. So then I will share my screen. You can just see my entire desktop. There we go. You have a few things?
Oh, go for it.
Okay. So we decided to tackle a very important need in the community, and we made a scientific vibe estimator based on abstracts under your ORCID ID on ADS. There's also an option for an author name, but sometimes it gets confused because it doesn't handle spaces so well. And for instance, I publish under the name J. Luna Zagoretz, and then it gets confused about whether J. Luna is my first name or whether my last name is Luna Zagoretz. So ORCID IDs are best. So it is called SciVibes. It is pip installable, and I'm gonna try to run it right now, and I'll zoom into my window here. You can appreciate my marvelous cow say. So it is going to fetch all of my abstracts that are on ADS under my ORCID ID. And then it is going to correlate my vibes with a subset of Reddit communities that have had a sentiment analysis neural net trained on them. So we can view my vibes, which looks something like this. We can view my anti-vibes, which looks something like this. So I'm not very bright green. And most importantly, we can view my vibestogram, which is a histogram of my vibes and anti-vibes. So as you can see, my top 3 vibes are skater, gamer, and cursed. And my bottom 3 vibes are geeky, anime, and jock.
It's important to note that you are zero anarcho-capitalist.
Right. I am 0% anarcho-capitalist, which probably means that I'm one and not the other. I'll leave it up to you to decide. And I'm 0% fantasy. So what can you do? So yeah, that's how it works.
Oh, we could show them our GitHub page so they can find us?
Yes, good idea. So it is pip installable. There are in their instructions on the Git. So it's under my Git and SciVibes. Note also that there is one fork. So we have found, do you want to explain?
Yeah, it uses the Cairo graphics library, and we have found that if you have an M1 chip in your Mac, it's very difficult to install that. So if you're trying to install it and you can't install PyCairo, try Homebrew. If you can't brew install it, then I have a fork which doesn't use Cairo. It means you don't get the really cool watercolor vibe plots, but you can at least get your vibestagram that way.
It's called Ugly SciVibes, I think.
That's my Twitter. Please don't show them that.
Okay, sorry, I was trying to find the fork, which I didn't know automatically how to do. So here we go, one fork, and it's called Ugly SciVibes.
Ugly SciVibes is not pip installable, but you can just clone it and run it.
Yeah, that's it.
Cool. Awesme. So for people on Zoom, if you want to present, just like let us know in the Zoom chat, or just like speak out now if you want to do a presentation. All right, it looks like we have one from group 2, so go ahead.
Hello. Can people
Hello.
hear and see me? Okay.
We do see you. In fact, you can see that we can see you.
Whoa. Okay, awesome. So I will screen share for group 2. Let me see. I'll start also by sharing like our Git page so people can get here and I can explain like what we did. So we made a package called InBody Builder, which basically lets you make a little tiny in-body simulation and lets you choose from different options. Like you can choose how many particles, you can choose what you want your gravity solver to be, you can choose like how you want to do the integration, you can choose time steps. So it's like kind of, it gives you the option to like abstract away like the challenge of like coding all of these and seeing like how like the in-body simulation would change, unless you just kind of like interactively with a GUI or with a text interface, like change different like options and flip different switches. And so we do have a guide for how to like try to get this on your computer. We also had like a little bit of an issue with like M1 chip, Mac OS type things, but it seems to be resolvable by like brew installing one of the modules as opposed to like relying on it to be installed with pip along the way. So yeah, I will show our package. Let's see, hopefully, I think you guys can see this. So it's already installed, so I'm not gonna install it again, but I'll just go ahead and show like how I run it. I will use the GUI option, which is just GUI. Oh, BN. So here's our little like GUI. I will note that if you do this on Windows, the GUI looks like it was from 1995. It looks surprisingly sleek on an OS Mac operating system. So yeah, you choose like a number of particles. You can choose a gravity solver. Start with like a random distribution or integrator. You can say we're chromer, time step, we'll leave that as 1. And do runtime 100, and then do run and plot. And I should get a pop-up. Maybe it doesn't like that. We have some bugs, it appears. Let me see. I think it's mad now. Let's see.
Murphy's Law of Life.
Yeah.
Okay, make sure you click submit.
Oh, thank you. Yes. This is also the challenge of making a GUI. Okay, there we go. Thanks, Ryan. So you can make, so of course in the settings I chose, most of them disappear. But yeah, like it's kind of fun to play around with. We have it currently set to where using the GUI, you can only do up to 10 particles. If you use a text interface, you can do 100 particles. It's a little slow. It's not terribly slow, but it's a little slow. There's also definitely some kinks to be worked out. Like, I don't know if it's physical, that when particles go on top of each other, they just shoot away. but but this is kind of where we've got a lot of ideas of where to go from here. But yeah, this is what we made. You should be able to get it on your computer and hopefully follow these steps so that you too can make a tiny in-body simulation.
Awesome. Well, let's give a round of applause for Stu. I don't know if you heard in Zoom land, but there's a lot of gasps in the audience once the animation started going. So everyone has really appreciated it.
Excellent.
All right. Anyone else want to present on Zoom? All right, group 11. Let's have group 11 go on Zoom, and then we'll have an in-person group go, and then we'll go back to Zoom again.
Yeah. So hi everyone, my name is Pratik and I'll be presenting for group 11. I'll share my screen. I hope it is visible. Yeah. So we came up with this quick short package called MagLimit. So it is basically a package to determine the observability of an astronomical object. We use the magnitude of the object and the telescope's limiting magnitude, as it is directly dependent on the aperture of the mirror or lens. So you can try this out by pip installing it, pip install maglimit, and or you can clone this repo. So I'll just quickly show the. So we also have hosted the documentation on Read the Docs, and you can check out the functions that you can use. And just a quick demo so that, yeah. Oh, I better show the demo here. Yeah. So we have imported this maglimit.limiting mag as ML, and we create this telescope object. We input the parameters in millimeters, and so this is a 100-meter aperture telescope, and we also input the f-stop number. So by doing this, oh, sorry. Yeah. So simply saying telescope.focal length will give out the focal length that is required given this f ratio. And we have also added this nice format of by using Astro per unit. So it gives out the unit also. And we also calculate limiting magnitude by just calling the limmag function. And further, so this is a function is object observable. So this takes in a parameter, say some Messier number or some NGC catalog number, and the limiting magnitude, which I have called here. And this gives out true or false if it can be observed using that telescope or not. It also prints the limiting magnitude of our telescope and the magnitude of the object. And so it will give out true if it can be observed, and false if the magnitude is larger than limiting magnitude. And we also added a function which can do the reverse of that. So say we want to see that if we want to observe this object, then what is the minimum aperture that is required to see this? So we basically need just the object to get the limiting magnitude and the aperture, but I have also added another parameter of the f-stop, and so we can determine the focal length also. So this gives out a tuple of 3 values. The first is the magnitude of the object. The second is the minimum aperture required. So in this case, to observe this, we need a 232 mm minimum aperture. And if we choose to have a f ratio of 4.5, we also need the focal length to be 1045. So the future goals of this package would be we would like to add the functionality of also choosing which catalog. So for now, we use the AstroPy net query, this AstroQuery ipec.net, this catalog to get the magnitudes of the Messier objects and the NGC objects. The one thing about this catalog is it does not have magnitude values for all the Messier objects. So this code actually, we realized that it fails on some of the Messier object values. So suppose I say M44, if I type M44, it gives out an error. So we want to take care of that by incorporating, say, our own CSV data file into the code so that we would need to query it on another catalog. And so yeah, this is it.
Awesome.
You
Thank
can
you.
install it.
Thanks. That was an awesome notebook and great to feature all those features. In person, I think we had a few other people that were interested in doing in person.
Go next.
You guys want to go next?
Oh, sure.
Come up. Come on down. You're our next contestant on Code Astro. Yeah, I saw that. I'll do that after this. Yeah, so just share your screen and then you should be good.
All right, let's see. Stop. Is that okay? That looks good. All right. I'm just gonna open a new terminal window. Those errors are embarrassing. Anyway, so our package, so my group is me, Jack, and Eureka. Jack and Eureka had to leave, so it's just me. So special shout out to them for an amazing work on this. So our package is called Solar Sys Daily. We basically can see what the solar system looks like on a particular date. So all you need to put in is a date, and you see a top-down view of the solar system. The best part, so what I like about just viewing the solar system from the top is that you could be oriented anyway, so it really doesn't matter. But we did check with the NASA solar system viewer, so the relative positions of our planets are actually accurate. And we did this by getting data from JPL horizons for each of the 8 planets, the RA deck, the heliocentric and geocentric distances, and we had to calculate the angular positions and to plot how exactly, like where exactly on the orbit they're located with respect to the sun. So I'm just going to do this step for the sake of doing it. So we pip install Solar Sys Daily. Actually, let me start IPython. Sorry, it's taking a little bit. Okay, pip install Solar Sys Daily, and it's probably already installed for me. Yeah. And it works, it should work also outside the Code Astro package. It should work with an older version of Python too. And so we import Solar Sys Daily. And you should get a secret message to infinity and beyond. And so we have 2 modules under this package. The first module is from Solar Sys Daily, import utils. Now utils is the one that actually gets your information for you. It has 2 main functions, one to generate the ephemeris data and the other to calculate angles from that. And then the other one is just a plotting package. So in that you would need to just put in the information you generated, and it should plot for you automatically. Solar Sys Daily, import plotting. Okay, so now I'm going to, so I guess we will just use today's date. Date is equal to, it has to be in this format because that's what JP Horizon reads. 25th June 2022. Okay, and then utils.gen fm today. That's the one that generates that generate or collects the information from JPL horizons. So it looks like that, but I should have saved it, so I'm just going to do it again. All right, and then the next step is to calculate some angles that you need for your plotting. So I'm just going to call it thetas. And so the way the angles work is from JPL horizons, we have the distance of, so we all know the distance from Earth to the sun. We also get the distance between the sun and the planet and the Earth. So using law of cosines, we get the sort of relative angular position at the sun, subtended at the sun by the line connecting sun to the planet and sun to the Earth. I think I explained that right. The detailed actual correct information is hosted on the read the docs for this one, so you can find it all there. So it's just called calc, and we put in the information we generated in the previous step, and it's been saved. Now on to plotting. So for plotting, we have three functions in that. One is plot all, which basically plots all the planets. And you can choose to whether or not to plot it with the true distance scales. We would advise to turn it off just because then the image gets a little weird if you're going to scale the distances between the sun and each of the planets. But if you actually want to see the distance scales, we have two other functions for that. One that plots all the inner planets, and the second one that plots the outer planets plus Mars, just to show where the terrestrial planets would be. So I'm just gonna demonstrate first plot all. So it's just gonna be plotting dot plot all. And for that, you would just need planet info, which you generate in the first step, and thetas from the second step. I'm hoping that's correct. Oh no. Maybe, let's see. Oh, it's, sorry. Yes, it's plot all A is uppercase. So yeah, that's what it looks like. That's what the solar system looks like today. Mars is like pretty much like, so you have I forgot to turn off true distances, but this is with distance scales. You can see all the inner planets smushed in the center. They're not at the sun, but in the outer planets. And then if you wanted to do just the, okay, I should close this. And if you want to do just the inner planets or outer planets, it would be the same thing. So plot outer. And this one just has one argument, planet info, I think. Oh no, it's, sorry, thetas. It already, because we already parsed planet info in this function. I think that's, wait, what? Plot outer. Thetas. Let's see. Oh, we do need both, I think. Just gonna copy paste this. Okay, I think we need the same information in both. Yeah, I didn't write the plotting function, that's I'm a little unfamiliar with it. But yeah, this is what the outer solar system looks like, plus Mars right in the center that's red. So yeah, this is a quick run through to our function. And yeah, we do have a GitHub. It's 1 second. It's right here somewhere. Let's see. Oh, there you go. So that's that. Our GitHub. It has a README that has all the information, and at the bottom of the README, we have a link to the read the docs for this one. Yeah, and so for the future release, so this is version 1.0.3 because it took me 2 versions to figure out. My computer thought August 32nd was a real date. So the future versions, one, we would include the asteroid belt, Pluto, and the Kuiper belt, because justice for Pluto. Then we also plan to include an animation where you could see how the planets would have moved over the orbits for one Earth year from the date you entered. And we were also we were thinking of including a feature that will let you display a random history fact for the day. The idea comes from Jack, who just put in a date and showed us a plot saying, this is what the solar system looked like when JFK was assassinated. So I thought that would be really funny and cool. So yeah, that's our future, that'll be version 1.1 something. Yeah, that was our project. Thank you.
Awesome job. Did we have someone else on Zoom that wanted to present? I think group 15 section. Go ahead. So
Hi,
I'm probably
everybody.
at least 2 more groups. Yep, go ahead.
Just a minute.
Yep, we can hear you.
Is it visible too?
Yep, we see your screen.
Cool. So, me and Gaurav Pandey from Group 15, we came up with a package called Peristol. I know it sounds funny, but before you guys say something, this is called peristole or peristalsis, and most of the astrophysical graphs look like this, weird, and maybe that's the feeling you feel when you're presenting to. So it's like gut wrenching or something like that. Most of the graphs do look like that. So that's why I just came up with peristole. So like Peristole is a package that generates time delay plots that are caused due to like the time delay caused due to gravitational lensing. And this project was inspired by a series of papers written by Roman Rafiko on the double pulsar binary pulsar system, which has a special case. The special case is that the companion pulsar in that binary pulsar system has an almost edge-on configuration with our line of sight. So these are the papers that kind of inspired us for this project. And the thing with like edge-on configuration is like as closer to 90 degrees, like as you get closer to 90 degrees, the effects that are caused by gravity are extreme. So let me walk you through like the code. So we have like different time delays that are caused due to different aspects like latitudinal, rotational time delay, and geometric time delay, and then gravitational time delay. And then there's also combined time delay, and there's also an amplification factor that's associated with all these time delays. So first, let's start with geometric time delay. And I know the code kind of looks long and unsegmented or unmodular, but the thing is like we can't have functions, like we can only have functions, not classes for this. We kind of try to shape this in a way such that a user can input anything that's scientifically relevant. Like they can input anything, and then they'll get a graph that is kind of accurate. So it like the geometric delay and most of the functions in our package take in semi-major axis, eccentricity, and the time period, periastron, and the inclination angle you want to check the graph for, and also the mass of the companion star. So let me run this quickly and show you a simple demo. So these are the these are the time delay that's caused to due to geometric lensing, and like gravitational lensing causes 2 different images, dominant and subdominant images, and most of the effects can be starkly seen on dominant images. That's why the focus is on dominant images. And similarly, we can also have the plot for like time delay caused due to gravity here. And then there's also a combined plot for both geometric and gravitational delay. And thanks to Gaurav for pulling in through, because I couldn't make it work, but he definitely did a great job with this. And then we have the amplification factor that can also be plotted through graphs. Just a minute. And yeah, it's not just that we are using these specific angles 0.14, 0.28, and 0.56, because these are the ones we can verify through the paper. but you can actually have anything like, for example, this. Yeah. And we are trying to come up with two more time delay graphs that are cost due to latitudinal lensing and rotational lensing. And here's a small sneak peek at what rotational lensing dominant image time delay looks like. And we have still not we have uploaded it on GitHub, but we are still not packaged it, but we'll soon do that too. Yes. Thank you.
Awesome. So it sounds like we have a few more groups that want to present, so we're going to try to squeeze everyone in if possible. So maybe if people can keep it short to like 3 minutes or so, we can try to get everyone in. Hillary, did you guys want to present first?
So just to start, our package is called Gaia Viz, and we built it for we had two main motivations in building our package. So we actually made that in the last 5 minutes. But our main motivation was that first was to show you the dynamic universe. When you look up at the sky, the stars seem stationary, but in truth, they're moving. So we wanted to bring that to everyone in a very accessible way. And then the second reason why I wanted to build it was to get people to play with Gaia data without much effort, get in on the Gaia fun with none of the work. So that is what we're trying to do today, and Alex will demonstrate. So what it does is you import a package called Sky Patch, and it takes a patch of sky and basically animates them forward in time. You can explain it more.
Yeah, so right now we just have the single module, which is the Sky Patch class. So you put in an RA and a deck for the center of the patch, and then a radius, and it does a circular query in Gaia for all objects within that radius. And then we just have a couple plotting functions that visualize this data. So
all the stars in that patch of sky, you can see them move forward in time 1 million years from now.
Yeah, let's just do that one. Keep it short, actually. So if you do skypatch.animate 2D star positions,
and it opens a browser window, and you can play it. Wow.
This was done using GalPy to integrate the orbits of the stars based on just the simple potential and the proper motion data that we had from Gaia.
Yeah, and the brighter it is, the bigger it is on the plot. And you can even just do the slider to move it back in time. Yeah.
There's obviously a lot more we could add, but this is the main functionality for now. So yeah.
Awesome. All right, that was awesome. Can you so you turn off the screen share, and then next, I lost track of who's supposed to present next. Give me 1 sec. Let's go back to Zoom. So, Hadi, did you want to group your group 24/4?
Yes, just a second. Okay, so unfortunately my teammate Duat is not here, so I'm presenting alone. So we build a code that can generate stars for a simple star population, or you can assume a global cluster. So let me show you the code. And I should say, unfortunately, our code just broke before the meeting today, and I don't know why pip install doesn't work, but whatever. We will fix it later. So what the code does is that basically you imported, we call it a star factory, and then you import it, and basically you need to have an input of isochrone, and isochrone are basically gonna show you how stars who have the same age and metallicity, how they would look like in a colorimetric diagram. So for example, here I'm showing you an example. This is here we have a colorimetric diagram. So this is magnitude, this is color. On the right, we have a redder star, bluer star. Bottom is faint, top is bright. So this is isochrone. So if you have a star with this specific age and metallicity, which is a very old population actually, that's where you expect them to be on the chromatic diagram. So what we do, we take that isochrone and we generate whatever stars, how many number of stars you want for a given distance modulus. And this is the kind of the theoretical magnitudes that you expect to observe. But then what we do, we include HST photometry uncertainties. So because that's not what you're going to observe, because there will be a lot of uncertainties involved. So when you apply when you change the uncertainty to true, this is what you get. So this is a more realistic observation that you expect to see if you look at a global cluster with that age using Hubble. And as you can see, in lower magnitudes, in fainter magnitudes, you have much more uncertainties. Things are pretty bad down there, but up there, stars are brighter, so they have less uncertainty, and they look like more of this kind of theoretical part. Yeah, so basically the input of the code is the isochrone, and the output is you can generate many stars for that isochrone and include HST uncertainties. And you can do this for different distance modulus, and also you can choose what signal to noise do you want. For example, do you want the signal to noise at main sequence turnoff to be 10, or do you want your red clump stars to have the signal to noise of 10? So you have this parameter that you can just play depending on what's your science goal. And yeah, so I will just keep it short, and this is the code. Yeah.
Awesome, thank you. That's great. Thanks for the demo. All right, next I think is Sabarish in group 31.
Yes, so let me share my screen. Yeah. This, sorry, just a minute. I opened the wrong one. Yeah. So this is a command line based Python package that can be used for converting redshifts to cosmological distances and redshift to time. And am I sharing the entire screen? Oh, let me reshare. Sorry. Yes. So all you'll have to do is you just, the name of the package is ztalks, and Z stands for redshift, and X could be either position or time. And then the command is to write ztalks. You just write ztalks, and then the redshift that you want to look at, say redshift of 0.1, and then it returns the age of the universe at that redshift, look back time, co-moving distance, and Hubble parameter at that redshift, and all of that. I came up with this package simply because every time I talk with a friend of mine talking about some recent observations, and then he says the object was observed at redshift 0.3, and I'm like, okay, what the hell is that? So it's just a very nifty way of just quickly computing the essential numbers. And another package that I worked on, but not like a couple of months back, but I would still like to talk about it, is a package that does unit conversions. And I can quickly show you how that works. So it's based on AstroPy. And then, for example, you want to work with natural units, you just say from unit convert or natural import all the functions. And then you have your AstroPy constants and AstroPy units. And this has the function called to natural. And then you say to natural meters, and then it goes to natural units. And then you can come back from natural units to SI units, and you just say from natural, the value, and then you want to go back to u dot mean meter again. So you take from natural, and then it returns you the conversion. And by default, the inbuilt systems that the package supports are Planck units, natural units, and Gaussian units, and also geometrized units. And in addition to that, it can also return the factors. So to understand what that is, I have this small notebook here. I mean, README file contains this. So here we have the equation E equals mc squared, and I've messed up the minus sign here. And in natural units, this becomes E is equal to m. And if you want to go back and plug in the constants in the equation, all you'll have to do is just say factor natural of the quantities in your equation. So you plug in E, for example, it has the dimensions energy, factor natural energy, you get zeros everywhere. So you just divide it by 1. And then if you have mass, you see that if you plug in U dot kilogram, you get the factor C being -2. And then you divide this quantity by C power -2, which is basically E is equal to mc squared. So you can also restore the constants in an equation. And this is particularly useful. For example, if you look at Maxwell's equation, in different unit systems, it has different constants. It just looks completely strange. And you can go about doing all these conversions with this. And another feature is it can also work with custom units. For example, if you don't want to use the speed of light, but you want to use the speed of your car, for instance, or whatever it is, like 100 kilometers an hour, you can create the units and you can call it strange, for instance, and you just create the units and then you load the units. The name of the unit system is strange, and then you have saved it locally. And then this returns 3 functions, 2 strange from strange, and the conversion factor that this unit system has. And the analogy holds good. You can basically use it like that. And you can do it for arbitrary unit systems. And that will be it. Now I think Maqsad will take over with the other package.
Hey everyone, I wanna talk about the second project of Group 31. Many astrophysical objects have a periodic nature, so our project was to make an algorithm that could detect such kind of periodicities. And we used a method called epoch folding, and you can see how it works. The algorithm is basically calculates the chi-square and tries to find the periodicity. Here you can see 2 possible situations. On the left, if we guessed the period correctly, and on the right, if we guessed it wrong. If we guess it wrong, we expect to see a uniform distribution of events per phase bin. But if there is a periodicity, we will see some kind of pulse profile. You can install it by this command. And now I want to show a small demo. I have already imported certain libraries. Here in our library, we have a periodic event generator. I have generated events with this period and with this mean count rate. Now I want to calculate the chi-square, and now I want to draw the periodogram, and here we can see that 42 is the answer. That's basically all our package, and I want to end my presentation with this one. Thank you very much. Bye.
Thanks, that was great. We're probably gonna run a little bit over time, so if folks need to sign off, please do so, but just we're trying to get all the groups in. So Ray, do you guys want to come up?
Find the correct one. Code. No, that's not it. Sorry, I have multiple VSQ windows open. Trying to find the one that I was. This one? Yes. Right here. Can you guys see this okay? Awesome. So hi, we made a package called Data Chef, and this was designed to help you create simulated data sets for whatever purposes you need. And it's made to be as flexible and easy to use as possible. So Data Chef has 2 main classes within it. First off, it has an ingredient class, which is basically a function of some sort, something that takes in an X array and gives out a Y array. And this could be a sine function, this could be something custom that you've built, this could be some scattered noise, some Gaussian noise. And then what we do is we take that and we add these ingredients into a recipe. So the recipe basically stores the functional form of how you want to generate your data.
And then once you have your recipe, you can go pass it an X-array and it will instantiate that to create a unique data set from your recipe. And the idea is you set up your recipe, you say, I need 1,000 simulated light curves, set up your recipe, and it will just go and give you a whole bunch of them. So hopefully make this as easy to put together your fake data as possible. So I'm gonna go ahead and pass it off to my partner here, who's gonna show you a quick tutorial.
Yeah, so here we have, this first line is just creating a basic ingredient. Here we specify the sinusoid function and a few parameters for that. So a phase, nothing, and then a period, and a custom period, and custom amplitude. And then we store that in this ingredient variable ing sign. We do something similar with some Gaussian noise, just pulling a Gaussian function, and again, parameters for that. And then we declare our recipe variable and add the ingredients to it. When you add multiple ingredients to a recipe, you need to say how you want to combine them as well. So we have various functions for doing that. For now, we're just using like simple addition for those two ingredients. And then here we'll go ahead and evaluate the recipe at these points, just a simple X grid. And you can see it's clearly a noisy sine wave, so it worked great. But you can do a lot more with that. We have many more hard-coded functions, and then also the ability to include custom functions. So here's another little more advanced example with a parabola, a cubic function, and a uniform white noise. Again, creating the ingredients, adding them to a recipe, and then evaluating it. And you can see this is like some weird combination of the parabola and the white noise. And then mixing in the cubic function to get some other weird stuff.
And you'll notice here we convolved it, so we use a different mixing function. So you can also write custom functions about how you want your ingredients to get mixed together.
Yeah, and I think we even like multiplied so we multiplied in the uniform white noise. Now, these are cool, but it's still not quite scientific yet. So we've also included some functionality to make mock additional wave signals. So here, this is code done by Peggy, our third partner. This will make a gravitational wave in spiral signal for a black hole binary with each at 10 solar masses and no spin. And we'll create the ingredient specifying we want this gravitational wave signal function. And again, say whatever timestamps we want to evaluate that function on. And we cook up the ingredient, and this is the output. Now, of course, we can still do the usual things like adding noise and other things to that. So here we have the same thing, but with added some simple white noise. You get a noisy gravitational wave signal.
There is more functionality that is not demonstrated here, but the data chef does have the ability to include uncertainties on your data, and it will propagate those through your recipe correctly as well. So if you need to keep track of uncertainties, it can do that. And it can print a summary of your recipe and all that. So hopefully you'll find this useful. I have an intention to keep working on this and adding functionality because I want to use this for my research too.
Awesome.
So cool.
Yeah. That was a really sleek demo there. I think we have one more group that wants to go. Pallavi, group 35.
Share screen. Hi everyone. So I'm just going to tell you sort of the context of our package. It takes inspiration from this thing called bionic reading. So if you look at this paragraph here, bionic reading is a way to change the font of a sentence in a way that will hopefully allow you to follow a sentence more faster. Or if you have any reading disabilities, it might also help you focus on the important parts of the sentence to encourage either better reading comprehension or just reading faster. Don't know how much scientific research is actually done on this, but yeah, take it away.
Yeah. So our program is called FRAP. It's font facilitated reading for archived PDF publications. And so basically what it does is it converts an archive paper into that kind of format, so that if that's a format that helps you, you can read a scientific paper and maybe be able to focus on it more easily. And so ideally it will work on the whole paper. Right now, I think we've proof of concept, we got it to work on the abstract, as long as it's in AppJ format. And so we can run a demonstration on how that works.
Yes. Yeah, so as you all know, we all have struggled with playing with the LaTeX file. So most of our time was, Kiara was working really hard in trying to add in all the conditions that you need to make sure it works. But we made it work on the AppJ format, the AAS format abstract or a text file. Oh, sorry, it already exists. So all you have to do is, for now, we do have it pip installable, but it's not kind of working at this point. So we just have a way of just doing a cloning, and you can then just clone it from the GitHub and install it. The usage is quite simple. All you need is just a archive paper code. As long as you have this digit number, you can put in a link or a URL or whatever, and it should work. Sorry, that's our confidence, because the LaTeX file, modifying a LaTeX file is like playing with a fire. Yeah, so, yep. So in the background, you also need any LaTeX compiler. For Mac, it's a MacTeX. And as long as you have that installed and the PDF LaTeX, you can just run this program. And if I open the PDF. Yep, it works. So yeah, I mean, I know we all hate reading archive papers, so maybe this will help. So yeah, that's our project. Okay, that was so cool. Thank you all so much for presenting. So I know you all have been sitting in this room or on this Zoom screen for a very long time, so I'm just gonna briefly sum up some concluding remarks. Okay, well, we made it through Code Astro 2020. 2022, sorry. Okay, not gonna analyze that. So I just want to remind you briefly about all the topics we covered. We did a lot this week. On day one, we talked about development environments, IDEs versus Jupyter notebooks versus plain text editors. Talked about different programming paradigms, object-oriented versus functional. And we went through a bunch of lightning fast best practices for different Python packages, focusing on NumPy, Pandas, Matplotlib, and AstroPy. Day two was all about Git and GitHub and Git flow. And we talked about debugging as well. On day three, we talked about releasing code, documenting code. We had that optional activity at the end about profiling code. And then day four, we talked about software testing. There's optional activity and demonstration about parallel processing. And then we talked about software and discrimination. So I can now put the goals up and say that you are now able to do all these things. You're able to use the language of software development. Once again, I'll remind you about the vocabulary list that'll stay up forever, so you can please keep adding to it and referring to it. You can develop and release an open source astronomy package, as we just saw. You all are extremely capable of doing that now. And you can write code that follows best practices of software development. I also just wanted to include this slide that we're not perfect, you're not perfect, we're all constantly improving. You'll probably at some point look at some code that I've written or someone else has written and be like, hey, didn't you say that you're not supposed to do that? And yeah. So I'll escape from that by saying that the best practices that we've presented are suggestions. It's not like you always have to do this.
And we don't always follow them, sometimes because it's not applicable in the particular moment, and sometimes because we're just not perfect coders. So yeah. I also wanted to put a slide up with some common feedback that we've gotten throughout the week that we'll work on for next week. One of the most common things is that the type along sessions went too fast, so we'll definitely work on making those slower. We get this feedback every year that there's lots of material and not enough time, and we keep trying to fix it, and it's hard. We'll keep trying. Some accessibility things that we'll work on for next year. We'll make sure in person we have all gender bathrooms accessible, and remembering to enable the live transcript at the start of each day. I think I did that like halfway through this first day and then also forgot today. So yeah, I'll try to do that automatically in the Zoom settings next year. And then we want to experiment more with a hybrid format. This is the first year that we did the hybrid format, and I think some things worked well and some things didn't. So we'll keep thinking about that. There's a final feedback form that I'll throw up in a second on slide 9, and I will give you all a little bit of time right now to fill it out. We would really, really love for you to give as detailed feedback as you possibly can so we can keep making the workshop better and better. And stay in touch. Discord and Piazza are going to stay up forever, and you're welcome to keep using them. The materials on GitHub as well will stay up forever. We'll keep improving those as well. We've been using the same GitHub for 3 years now, and so folks that took this workshop in 2020 now have, still the updated, most updated version of everything. We've also posted all the answer keys for all the activities. So even if you go back like in 6 months and you're looking at one of the optional activities or something, you should have access to all the answers, quote unquote. We'd also just love for you to stay in touch with us in general. All the TAs and instructors' current contact infos in the intro slides. And yeah. Oops. I just wanted to take a second to give a huge round of applause to our amazing TAs. To the TAs, you are incredible. This workshop would not happen at all without you, and you're quite literally the face of the workshop. So I can't thank you enough for everything you've done. I want to thank Denise as well, who is here this morning, and also thanks to the Heising-Simons Foundation for giving us money. Also want to give a huge thank you to Judy, who has been working tirelessly behind the scenes to help us with logistics for the workshop. She was here at 7:30 on the first day to make sure that all of the catering got delivered. She helped us out with hotel stuff, and she's going to be processing reimbursements. She's going to be working really hard and has been working really hard for this workshop. So she's not here, but I still want to give her a huge round of applause. And then also thanks to the staff at the Hilton and to Caltech Catering for keeping us fed and housed. And most importantly, thank you to all of you. Give yourselves a round of applause.